ID paper number 9. The title is BIM-assisted automated processes for commissioning in building services engineering. And bear with me for the list of authors here, and excuse my accent if it's not accurate. Ralph Becker, Christoph Blatt, Christoph Amans, Jerome Fries, Dirk Hederman, Tristan, Kinnen, Alexander Lenz, Michael Moller, Niklas Pohn, Tobias Ratig, Dominic Schlatter, Matthias Wenthe, Hork Blankenbeck, Gunter Bleeman-Gather, Johannes Fatterer, Hork Dietrich, and Christoph Weintrick. Okay. Thank you.
Thank you.
Okay.
Okay. So thank you very much for the introduction. Yes, as you can see, we're actually a quite big research project where we're cooperating with 2 institutes and several companies from Germany. So this is the reason why we have this long list of authors. Thank you very much once again for your effort to read them all. Yes, we want to present to you today our research project. We call it energyTWIN, where we deal with BIM-assisted automated processes for commissioning in building services and engineering. So this is still an ongoing research project. So today I would like to present you what is the idea of the, what are our first results, and to do in future. So maybe if we start. Sorry. Oh, okay. Sorry, we have to share the screen, I heard. Okay, thank you very much. So to start with the background, we are focusing on the technical building equipment, which is almost everywhere, in all times, a highly complex systems where we're dealing with a huge amount of data, which is usually not standardized or structured. So there's a high interest in digitalization and automation, and we want to build a system up to get all these data in a structured way that it's readable for humans, and therefore we can use it to optimize the energy systems and buildings in the commissioning and operation phase. So the basic idea would be to create a digital twin of the energetic systems, and therefore we are challenging a few tasks. First of all, like the data of the actual state in terms of geometry, topology, and condition is actually not often existed, fragmented, or outdated. So we also have to, as I mentioned before, focusing on the challenging task that a lot of the data is neither usually not standardized or structured. So in terms to build up a digital twin, we have to focus on the task for acquisition of the data, identification them, get the functional connection, and in particular means, okay, we have to go ahead after we have our data capturing to segment the reality capture data, classify the object, or even identify the BIM entities. We have to interpret the data that we get from each component of the TBE, link them to the particular BIM entities, and therefrom we can go ahead and derive topology and functional informations. So as a go, maybe if you have one component where we get the data structured about what is it, who's the manufacturer, which kind of data do we have, how can we interpret it, where is it located, and even go ahead and bring something up like a navigation. So how can I get there? To do this, we have a methodology with several parts. The first thing would be to reality capturing. We are going to explain every part of it in the next slides. So we have reality capturing, artificial intelligence to classify it, electronic data at field level or at cloud. We need something like an indoor positioning. We are also dealing with virtual and augmented reality. And give every component of the TBE a general identification. We also came ahead and designed a reference designation system. So from all these components, we bring them together for an intelligent data fusion. And from this on, we can go ahead and automate the comparison of the as built and as planned, so that we, as a result, we get as is BIM, structured data from the components of the TBE, which give it, which we can deal with the complexity management, and for the future, for planning operation and processes, we are then dealing with a 5D BIM to optimize the TBE systems. So maybe go through all these components. The first one is the reference designation system. This one's actually done. We did a lot of which standards there are, what can we do, and our own system based on the ISO 81346. And you can see an example on the slide, like we have 44 digits for each component, and digit 3 to 18 would define the location. 20 to 34 would define the structure and so on. So as an example, from each component, digit 3 and 4 will give us information about the site, and the digit 29 to 34 would just give the information about which product are we dealing with. For the reality capturing part, we were thinking about how to do it the most effective way. So we wanted a flexible and easy to use system that it's not quite necessary to bring out experts to do the data acquisition. So what we need from the data acquisition but is the geometry, visual information. We get those from the RGB camera and additional properties of the TBE. And because we are talking about optimization of energetic systems, we came ahead with thermal data. So to get all of these together, we built up a data acquisition system with the HoloLens, Microsoft HoloLens 2, which has inbuilt sensors like a depth camera and an RGB camera, which are always calibrated to each other, and you can get those information directly from the hardware. And we were calibrating an external thermal camera, in this case, the FLIR 80K camera, to it with a 3D printed mount to get an easy data acquisition system. So the goal from this one would be a co-registration with the thermal data. On the one hand, we want to generate colored point clouds with the RGB data and as well with the thermal data. And on the other hand, we want to use the thermal data to overlay it in the real scene. So when we have these information, we got the data capturing, then we need to classify our components. Therefore, we have to use artificial intelligence for the element recognition and the classification. We use this for the classification of the components, as planned automate, as planned as built comparison, and derive about the topological functional information relationship. So for that, we defined an initial situation. Like we always have an as planned model, and we have our point cloud from the HoloLens. And for our initial situation for the artificial intelligence, we say those are always registered to each other and are in a common coordinate system. From there on, we can go ahead and analyze each component of the TBE on 3 different ways. Actually, we are doing research in all of these different ways, directions. The first one would be knowledge base, which means that we can use the data that we already got from the as planned model in terms of geometry, of proposed location. So we take these information that we already got and try to use it to classify the objects or components in the as-built data. The other one would be the geometry-based methods, where you can analyze the point cloud with the neighbors, normals, or doing approaches of voxelization and register system to each other to make it something like this. And of course, we also do learning, but few people of you know it. It's not that easy to get training data in this part. It would be from each component. It exists. It doesn't exist. Component at the location where we're looking at, and this component could be, if it exists, rotated or displaced, or one of it, or it could be the same way that we would expect it. So this is my part, and now I would hand over to my project partner, Matthias Wenthe.
Yeah, thanks a lot, Tristan. There, I'm Matthias Wenthe. I'm working for one of the private companies there, aforementioned in Germany. We've been doing research with the chair of computing of RWTH University in Aachen for quite a few years now, and there are a few research projects. This is the second or third one, which nicely connects to, wrong direction. To the next slide there, the question is, with all these data of the BIM model and the captured data, where do we store the data? So we developed a so-called content server, as we call it. What you see here on the right slide is the technical building equipment of a laboratory demonstrator, which is used for research and educational purposes in one of the experiment halls in Aachen University. On the second floor of this demo, you might recognize the bathtub there and the two sinks. There are two different bathrooms, and on the base level there's a heating system, and highlighted in green there's a buffer system. So what does the cloud server store? The cloud server stores the IFC BIM model, topological data provided by one of the partners there, sensor data of IoT building sensors, scan data, as before mentioned, from the Microsoft HoloLens, and we are currently developing a ticket system for BCF change requests. This is all stored in a server programmed with the Symfony PHP framework, and this has an API. And what we see here is a progressive web app, which works nicely on the desktop and mobile device, and this is connected via the API. The front end is programmed in the Node.js JavaScript framework. We are assembling some data from third-party APIs from project partners, and we have a common API for all these data requests. This API is used by two programs on the Microsoft HoloLens again. So we have virtual reality for offsite comparison of the as-built, as-planned model, and we have augmented reality of on-site comparison methods. The two pictures on the right are virtual reality pictures. So with a microphone on your head, you can compare the BIM model with the point cloud data and might find some deviation point cloud data and the BIM model. Whereas if you're on site, you can use augmented reality, and I can show you this on the next little piece of footage I have here. An interesting question with augmented reality on smartphones, you might know that is always how to track the pose in order to place augmented reality objects into the reality. You might know that you scan a marker or a QR code in order to track the pose. We have a different approach here. There's chaos right now. You see the laboratory demonstrator and the AR objects not aligned. In order to do that, we are placing three purple colored balls here at the base of the metal columns that support the whole structure. That's the second ball, so that's the second point to align the whole model. And once we've placed the third ball, we have enough data for the actual alignment. So the user there in a few seconds will look at his palm, and by that that's the gesture that triggers the pull down menu there, and he presses the align function, and then whoosh, now it's aligned. And look at that, that's very beautiful now. The heating system is now highlighted in blue color, and it's very easy to spot any deviation between the as-built and as-planned model there. So that was the laboratory demonstrator. So in conclusion, we are introducing some digital processes in combination with the BIM model in order to support the commissioning process of energy systems, of technical building equipments. We were using indoor positioning, VR and AR techniques, various IoT building sensors, and captured data from the Microsoft HoloLens. We use some artificial intelligence-based object classification by means of geometry, topological, and function for the actual built as planned comparison. And we have a cloud-based system in the server system that we hope that will continue to work for the users of this building over the whole life cycle and maintenance cycle, which could easily be 100 years. So it's an interesting question, what will happen with all the programming languages and all the data we're using now? Will that convert in the future? I'm not so sure about. So there's a lot of work going on there. So for future research, in order to increase the accuracy of the capturing system, we have to increase the automation level. We have to do a lot of work there, and we have heard over the conference a lot about the complicated task of segmenting point clouds. So that's by means of artificial intelligence. So that's a challenge we are facing here as well. We're in the middle of the research project, so there's quite some work to be done there. Another interesting thing is the actual indoor positioning with Wi-Fi or Bluetooth or whatever. This has been a task my company has been focusing on for the last couple of years, and I think the Holy Grail is not found there. I think many of us will concur with that. And the last but not least, acquisition of additional data sources like clamp-on sensors you can put on tube systems in order to measure temperatures, or traditional things like type plates would be helpful, and there's some research to be done there as well. I'd like to thank the German government, especially the Federal Ministry for Economic Affairs and Climate Action. They kindly supported the research project there. And I thank you very much, ladies and gentlemen, for your attention, and we're happy to answer your questions now. Thank you.
Okay, thank you very much, Tristan and Matthias. Is there any questions from the audience?
Fascinating project. Also very ambitious at the same time. There's a lot of different scope to it. I'm curious to hear your thoughts on two parts of your presentation. The new classification that you've put together. Later in your presentation, you showed a system that was driven by IFC. So I'm wondering why you didn't look into omni-class or unique format classes based on your presentation. Instead, you came up with your own. I'd love to hear your thoughts on that. Second piece is, there was a BIM model that I'm guessing you're using a BIM model that may not exactly represent the as-built conditions on the job site. And now you want to update that based on your recognition. So I'm wondering if you've looked into maybe leveraging that BIM model to train synthetic data that can be used for the purpose of detecting those changes or objects in place, if you've explored that. Thank you.
Maybe let me start with your second question. We're actually doing this because we had a lot of meetings and we were discussing how can we get there, how do we get the trainings data. Doesn't work. So this is what we are doing right now. We build up synthetic point clouds from the BIM models that we have, or even from other BIM models that we can collect, and try to work our deep learning on this one. But this is an ongoing process, so I don't have any further information about that. And I'm sorry, I didn't.
First one was, I think you presented a classification system for building systems, right? Yeah. That is unique to your work. And I'm questioning why use this one as opposed to, let's say, omni-class that is already embedded in the IFC representation that you have.
We are cooperating with a company which gave us access to their TVE components and built it up for us. And within this is a demonstrator Matthias showed us. And there are so many different components. And we had a team on the research for the reference designation system. And in cooperation with the company, they decided to, we want it in an international standard, but we want to design it directly to our components. So this is why they did it in this way.
Well, excellent work, and thank you for sharing.
Thank you very much.
Well, thank you, Mani, for your very insightful questions. I think we have to move on to the next presentation. So let's thank Tristan